Welcome to HSC Math. I'm Joy Song and I will be going over polynomials. From the literal definition to how to factor polynomials, I will be covering the basics of polynomials in two parts. This is part 2, multiplying, dividing, and factoring polynomials. First, we will refresh our knowledge of polynomials. Then we will move on to multiplying and dividing polynomials, and finally, we will learn how to factor polynomials. Here's a quick review on polynomials. A polynomial is defined as a combination of many terms. Things like x, 8, 3x, or 19x squared minus 2 are all polynomials. A term which makes up a polynomial is a single number or variable. Some concepts we went over last time are simplifying, adding, and subtracting polynomials. In simplifying polynomials, it is just like combining like terms. If the variables and degree is similar, it can be combined. Adding and subtracting polynomials are very similar as well. The only main difference is in subtracting polynomials, you have to release the parentheses using distributive property. Finally, the last term I'd like to define is like terms, meaning terms whose variables with any exponents are the same. For a more in-depth review on these topics, the part 1 of polynomials contains more examples and definitions. Multiplying polynomials. When multiplying monomials or monomials and binomials, the easiest way to do this is to use the distributive property. Take 4 times y plus 5, for example. Multiply the 4 with both of the terms in y plus 5. This will bring you to 4y plus 20, and that is your final answer. Here's an example, 7 times 4y minus 2. First, distribute 7 to 4y and negative 2. Multiply 7 times 4y and 7 times negative 2. Your final answer should be 28y minus 14. Now that you know how to multiply monomials with binomials, we can move on to binomials and trinomials. One of the easiest ways to multiply two binomials together is using the FOIL strategy. FOIL stands for first, outers, inners, and last. FOIL indicates what terms need to be multiplied. First is for the first terms of both binomials. In the example, this would be a and c. Outers is for two outside terms of both of the binomials. This would be a and d. Inners is for the two inner terms b and c. And finally, last, the two last terms b and d. What you would get as a result of FOIL would be AC plus AD plus BC plus BD. The other way to do this when you're not multiplying two binomials is to just use the distributive property. Multiply each term of the second polynomial with the first term of the first polynomial. Then repeat the process with the second term of the first polynomial. Then combine like terms. Here's an example problem. 2a plus 3b times 4c minus 5d. For this particular example, you can use FOIL. The parts our FOILed are labeled, so try to multiply them on your own. You should have gotten something like this. The first becomes a times AC, the outers become negative 10 times AD, the inners become 7 times BC, and the last become negative 15 times BD. Next up is dividing polynomials. Dividing polynomials is relatively simple. Split the terms on the numerator to create two different fractions. In the example here, x plus y is being divided by z. So, x plus y divided by z can be split into x over z and y over z. From here, simplify these two fractions if possible. In this example, 6x minus 3 is being divided by 3. First, you'll want to separate the one fraction into two fractions, 6x over 3 and 3 over 3. From here, you can see that both of these fractions can be simplified. After simplifying, the answer will be 2x minus 1. Finally, let's learn how to factor polynomials. Factoring polynomials using a common factor is like reverse distributive property. Take 2x plus 6, for example. Both terms can be divided by 2. 2x divided by 2 is x, and 6 divided by 2 is 3. So what we do is we take out the 2 and put the quotients in parentheses. The answer to this problem would be 2 times x plus 3. Here's an example. Before I explain it, try to figure it out on your own. So the common factor in this problem is 16. 16a divided by 16 is a, and 32b divided by 16 is 2b. Once we take out the 16, it becomes 16 times a minus 2b. When the polynomial we are factoring does not have a common factor, we can use special binomial products to solve. Let's take 9x squared plus 16 for example. As you might have noticed, 9x squared and 16 are perfect squares, so you can take the square root of both of these terms. This will equal 3x and 4. Now, if you add this back into the polynomial, you get 9x squared plus 16 equals 3x squared minus 4 squared. Using the distance of squares formula, we can conclude that 9x squared plus 16 is equal to 3x plus 4 times 3x minus 4. Here's an example you can try. 25b squared minus 81. These terms are both perfect squares. Once we take the square root of them, they become 5b and 9. Once we add them back into the polynomial, it should look something like this. Finally, using the distance of squares formula, 25b squared minus 81 is equal to 5b plus 9 times 5b minus 9. Now let's review the topics we learned today. Multiplying polynomials can be done in two ways, using the distributive property or using FOIL, which stands for firsts, outers, inners, and lasts. When you're dividing polynomials, split the terms on the numerator to make two different fractions. And finally, when you're factoring polynomials, you can either use a common factor if applicable, or you can use special binomial factors. And that's how you multiply, divide, and factor polynomials. Thanks for listening.